Students, in this video I'm going to do mostly solving linear equations. There will be a few non-linear equations at the very end of this video because there are some at the end of your exercises in this textbook as well. In these cases, the x will always be raised to some power, either a 2 or a 5 in these problems on this video, but technically you work any variable raised to a power the same way. Now, I want you to notice as you go through this video that everything that I add to the problem on each side of the equation will be notated in red. And the first thing you'll see after this introduction is the same list of things that I told you to do whenever you approach a linear word problem. Whenever you approach a linear equation that you're trying to solve. There's 3 steps that you need to do. Either you've written them down in class, or I'll briefly show them to you here on this video. You do those steps in that order. I certainly do on every problem that I do in this demonstration, and you will arrive at the correct solution. Let's take a look at our first equation. Now this is a very simple linear equation. And the key to this is to always remember that we have to do the opposite of what we're doing to our variable. In this case, we're adding 2 to our variable. So what we literally do is go ahead and subtract 2 from both sides of the equation. Remember from our class lecture, the way we need to treat this is that you have 2 things that are equal, and as long as we perform the same operation to both sides of the equation, we end up with 2 things that are equal. So if I subtract 2 from both sides of the equation, they are still equal. Now I simplify. The 2 minus 2, of course, cancels out, and I'm left with x. And then, of course, 6 minus 2 is 4, which, of course, is our answer. This is our goal, to come down to be left with just the variable we're trying to solve for on one side of the equation by itself. Let's take a look now at another simple example. In number 2, we have the problem 3x equals 12. What I'll do this time is understand that that's 3 times x. I do the opposite, which means divide. So I divide both sides by 3. And in this case, the 3 divided by 3 cancels on the left. And I'm left with just my x. And of course, 12 divided by 3 gives me my final answer of 4. I'd like to do one more simple equation here. In this case, we have a fraction actually, x over 3. Now what I'd like you to understand here is that the understood operation between the x and the 3 is division. You need to look at this as x divided by 3. The opposite of dividing by 3 would be, of course, multiplying by 3. So I will multiply both sides of my equation by 3. In this case, again, my 3's cancel, and I have x equals 5 times 3, or in other words, x equals 15. Let's go ahead now and look at an equation involving 2 operations. In this case, I have 3 times x plus 5 equals 7. Now remember, I went through a list of rules for you in class that would help you solve every problem. And in this case, what I want to do is eliminate the term without the x. I want to subtract 5 from both sides of my equation. It may be useful to you to pull out that sheet that I put up at the beginning of this video. Hopefully you copied it down or you took good notes in class so you have those steps written down to follow as a guide until you get good at working these equations on your own. But at any rate, I need to eliminate my 5, my term without an x first, so I will subtract 5 from both sides of my equation. On the left side, my 5's will cancel, and on the right side, I have 7 minus 5 is 2. So I'm left with 3x equals 2. Now I have 3 times x. The opposite would be to divide both sides by 3. On the left side, once again, my 3's will cancel, and I have my final answer of x equals 2/3. Now the equations are going to continue to get more complicated. In this case, I have my equation negative 2x plus 7 equals negative 5x plus 4. Again, following along with the steps that I gave you in class, what you want to do is to eliminate the smallest variable term. In this case, that means I want to eliminate negative 5x because that is smaller than negative 2x. I will eliminate negative 5x by doing the opposite again. I will add 5x to both sides of my equation. Once again, on the right side, those do cancel, and I'm left with just a 4. Combining the terms on the left side, I have a negative 2x and a positive 5x, leaves me with a 3x plus 7. Now, I will solve this essentially the way I did the last example. I need to get rid of the term without the x. That's the plus 7. I will eliminate that by subtracting 7 from both sides of my equation. Again, the 7's on the left will cancel, and I'll just be left with my 3x. On the right side, 7 minus 4 is negative 3. And now I merely need to get rid of the coefficient by dividing both sides of my equation by the 3. On the left, the 3's cancel, and I'm left with x equals negative 3 divided by 3, or x equals negative 1. Let's go ahead and look at our next example. Again, I'm going to start making these more and more complicated. In this case, I've got two sets of parentheses. I've got to do step 1, which is to simplify my equation. Multiplying through the equation will eliminate the parentheses, and I'll be left with 3 times 3x is 9x, 3 times 7 is 21. On the right side, 2 times the 5x is 10x, and 2 times the 7 is 14. I will now combine my like terms on each side of the equation, but the only like terms I really have in this case are my 4 and 14, which combine to give me a plus 18. Now I need to eliminate my smaller variable. That would be the 9x in this case. To eliminate the 9x, I will merely subtract 9x from both sides of my equation. On the left, again, those cancel, and I'll be left with 21. On the right side, I'll combine my like terms, where I have 10x minus 9x is 1x plus 18. Now the only thing I have left to do is to eliminate my plus 18. I will go ahead and subtract 18 from both sides of my equation. On the right side, these cancel. On the left, I have 21 minus 18, which is 3. So I have my final answer, x equals 3. Let's go ahead and take a look at an equation with fractions in it. Now step 1 this time will be to eliminate the fractions. Again, we always want to simplify, and eliminating fractions is definitely something that will simplify our equation. So in this case, I need to find the least common denominator. So my first denominator is just a 3. My second denominator is a 6, but 6, remember, is equal to 2 times 3. And my last denominator is 9, which factors down to 3 times 3. So, if I want a number that all three of these numbers divide into, remember, you have to have all the factors. In other words, if I want something 3 divides into, my least common denominator must include a 3. If I want something that 2 times 3 or 6 divides into, then my list must include a 2 times 3. Well, I've already got the 3. I'll merely add the 2 to my list. Now I have 2 times 3 is 6, and my number is also divisible by 6. Finally, I have to have my denominator be divisible by 9, which is 3 times 3. So 3 times 3 has to be on my list. I have the 3, I merely add the extra 3, and I now have my common denominator, which is 18. Now quite simply, what I'll do to both sides of my equation is multiply both sides by 18. Now you may remember in class I did this in factored form. You may prefer to actually do all of these numbers in factored form as opposed to the way that I'll do it here. But if you're happy with the simple arithmetic, in this case there's really no reason to do this. So first thing I have to do is distribute my 18 through both parentheses. I'll in essence be taking 18 times every term in the entire equation. And now what I need to reduce is to reduce. This needs to be thought of as 18 over 1. And the 3 and the 18 cancel and leave me with a 6 times 5 is 30x. The 6 and the 18 cancel and leave me with a 3, and the 3 times 7 is 21. And now I have my 9 cancels with the 18 is 2, and the 2 times 11 would be 22, and finally I have the 18 times 2 is 36. Now I've unfortunately shown you an extra step here inadvertently. Let me just cover that up for a minute. This was what my original equation was. At this point I need to eliminate my smaller x. So in this case I need to eliminate my 22. I will do that by putting a negative 22 on the right and a negative 22 on the left, which will simplify, leaving me with an 8x on the right plus 21, on the left, and on the right those cancel and I'm left with just the 36. Now I've got x on one side by itself. I need to eliminate the 21 by subtracting 21 from both sides of the equation, and I'm left with 8x on the left and 36 minus 21, or 15, on the right. My final step is to merely divide by the 8 on both sides of the equation. You can leave your answer, by the way, in this form if you wish, 15/8. It's a reduced improper fraction, or 1 7/8. But in this case, I've gone ahead and done what I think most of you will do on the exam, which is to list it as a decimal, 1.875. Let's take a look at our next example. It's a little more complicated again, but there's no fractions at least this time. Let's go ahead and distribute my 5 through my parentheses, which will give me 5 times x and 5 times 2, or in other words 5 times 5x and 20. Now I have some like terms that I have to simplify.
20?
I'm sorry, 5 times 2, which is 10. I've distributed the 5 through the parentheses. 5 times x is 5x. 5 times 2 is 10. That was my mistake. I apologize. Good catch, Luann. And now I need to simplify by combining my like terms. My 5x minus 3x is 2x. And I have 2x plus 10. On the right side, I have 2x plus 12. Well, my next step is to get rid of the smallest variable. They're actually the same variable if you want to be honest about it. It's 2x. I will eliminate those by subtracting 2x from both sides of the equation. But unfortunately, what happens this time is I lose all my variables, and I'm left simply with 10 equals 12. Well, that's not possible. 10 never equals 12. So no matter what you plug in for x, this is telling you that you're going to end up with a false statement, such as 10 equals 12. Well, in that case, if it is never true, that means no matter what you plug in for x will make the equation true. So this equation actually has no solution. You can merely put down the words no solution, or if you prefer, you could put the symbol for the empty set, telling everyone, in essence, the same thing, that this equation has no solution. Now, let's take a look at another fraction equation. I want to approach this the same way that I did the other equation, and I'm going to multiply by my least common denominator. Well, I want you to notice that this one doesn't factor at all, so I'll need to multiply both sides by a 7. This one doesn't factor at all, so I also need to multiply both sides by 4x minus 7. So in other words, I have to multiply both sides of my equation by 7 times 4x minus 7. Since I have these written as fractions, let's go ahead and write my common denominator as a fraction by merely putting it over 1. Do you see what's going to happen at this point? The 4x minus 7 will cancel from the one on the left, and the 7 will cancel from the one on the right, and I'll be left with 7 times 2x plus 3 and 5 times 4x minus 7. What I would like you to notice, though, is that's the same thing you get if you apply a technique that you probably learned in high school called cross multiplication. On the right, I have 5 times 4x minus 7. On the left, I have 7 times 2x plus 3. So what most people do, frankly, rather than look for a common denominator and multiply through both sides of the equation, the way we did when we had 3 fractions, if you have only 2 fractions, you merely cross multiply, and it's a much more elegant and easy solution. Now let's go ahead and distribute my 7 and my 5. 7 times 2 is 14, 7 times 3 is 21, and on the right side 5 times 4x is 20x, and 5 times negative 7 is negative 35. This is the step you get after you distribute. Once again, I've got a 14x and a 20x. I have to eliminate the smaller, which would be the 14. So I will subtract the 14x from both sides. On the left, these will cancel, and I will be left with only the 21. On the right, I have 20x minus 14x, which will leave me with 6x, and I'll negative 35 still. Now on the side with the x, I need to eliminate the minus 35. I will accomplish that by putting a plus 35 on both sides of the equation. The minus 35's cancel. The minus 35 cancels with the plus 35, and I'm left with merely 6x on the right. 21 plus 35 is 56. And my final step is to merely divide by the coefficient of 6. The 6's will cancel, and it looks like I'm done, frankly. And as a matter of fact, if you wish, you could just merely plug this one into your calculator, 56 divided by 6, and come up with an answer. But just for demonstration purposes, I left this one as a fraction. But you better notice something if you choose to do this. It is the easier, more elegant solution, if you will, and you don't have to pick up your calculator, and you can be a little lazy. But you'd better notice that both the denominator and the numerator have a common factor of 2. Dividing top and bottom by 2, reducing my fraction, leaves me with my final answer. Failure to reduce a fraction like this on the test will result in your losing half credit. Let's take a look at a more complicated question still. This one has braces, brackets, and parentheses in it. I'll begin by looking at the innermost. Notice that I have a bracket, inside of which I have a parenthesis, inside of which I have a brace. Now, I'm going to go ahead and do the inside first. I'm going to go ahead and distribute through my brace. The negative 3 times x is negative 3x, and the negative 3 times the negative 2 is plus 6. I go ahead and just copy down everything else. Now, you have to make a choice at this point. You could do some simplification if you wished. You could go ahead and combine the x and the negative 3x and make that a negative 2x inside the parenthesis. I've chosen to forego combining my like terms until I eliminate all my brackets and parentheses. So I've gone ahead and just distributed the negative 2 through my parenthesis. Negative 2 times x is negative 2x. Negative 2 times negative 3x is positive 6x. Negative 2 times positive 6 is negative 12. And that gives me my next line. And once again, you'll notice I've copied down all the other terms. Now, let's go ahead and finally distribute the negative 2 through my bracket. You could have, again, chosen, if you preferred, to go ahead and combine your like terms, but again, I'm going to forego that until I've gone and eliminated all my brackets and parentheses. Distributing the negative 2 gives me negative 2 times 5 is negative 10, negative 2 times negative 2x is positive 4x, negative 2 times 6x is negative 12, and negative 2 times negative 12 is positive 24. And once again, I merely copy down the rest of my equation. Now I'm going to go ahead and combine my like terms. On the left here, you'll notice I have positive 4x's and negative 12. I like to think of this as if I won 4x's at the crap table, if you will, and then on my next bet I lost 12x's. that actually leaves me 8 x's in the whole. Or in other words, when I combine these terms, I have negative 8x. On the positive side of the numbers, I won $5 and I won 24, so I've won a total of 29, but I lose 10, and that means I still have 19 left over. When I combine my like terms, I have negative 8x and a positive 19, as I suggested from before here. Now, you may notice at this point that that's exactly what you have on the right side of the equation. You could quit at this point, but most students take it one step further and eliminate their variable, their negative 8x. I will do that by adding 8x to both sides of the equation. Now, that leaves me with 19 equals 19. Now, you remember on our last problem, you ended up with a false statement. 10 equals 12, which is never true. It's always false, and therefore the equation is always false no matter what. There was no possible solution. Well, this is the opposite. 19 does indeed equal 19. It always does. So in this case, no matter what you plug in for x, it will work. So on this problem, you need to say that the solution is all solutions. Let's look at another little interesting twist here. It's another fraction problem, and this time I have 3 terms. These 2 terms, remember, on the right side of the equation are separated by this addition sign. I will eliminate the fractions, as always, by multiplying both sides by x minus 2. Now, I know there are other things you could do here. You could combine those like terms by coming up with a like denominator, for instance. You can always work a problem differently than I do on the video or in class, but I tend to always show what I think works best for most students. And that's no different here. So I will multiply both sides of my equation by x minus 2. Now once again, I'm going to rewrite where I'm multiplying the x minus 2 in fraction form where it's appropriate. So I take x minus 2 times this fraction. Let's go ahead and write it in fraction form so that you can see the numerator and denominator cancel. When I take my x minus 2 times my 2, I just merely write it that way, because that's easier for you. But when I write x minus 2 times this fraction, I will go ahead and write it as a fraction again, x minus 2 over 1. Recalling, of course, that I could take anything and stick it over 1, and it's an equivalent fraction, the equivalent expression, excuse me. At least on this case, what I want you to see is the x minus 2's cancel again. So on the left side, I am left with just a 2. On the right side, I will distribute the 2 through my parentheses, and I'll have a 2 times x, and a 2 times negative 2 is negative 4. On the right side, when my x minus 2 is canceled, I am left with a plus x. Now let's go ahead and combine our like terms. I have a 2x plus x is 3x, and I have 3x minus 4. I have 3x minus 4 equals 2. I will now solve this by adding 4 to both sides of the equation. Let's go ahead and put a plus 4 on both sides of the equation. On the right side, these will cancel, and I'll be left with a 3x. On the left side, I'll have 2 plus 4, or 6. So I have 6 equals 3x. Finally, I divide both sides of my equation by 3. On the right side, the 3's cancel, and I'm left with x equals 6 divided by 3, or 2. Now, I need to check this answer. Briefly, what I need you folks to see, and obviously we have a guest at the door, and I've got to go answer the door here, but quickly, what I want you to know, when you plug in your 2 to check your answer, what happens? Both this denominator and this one would result in a 0. You cannot have a 0 in the denominator, folks. That can't be done. So what looked like a solution wasn't a solution after all. Now, I've been bad. I've been not giving you a good example by checking every problem. I checked one and one only in the interest of time to prove to you that if you've done it correctly, it always works when you plug the number in. This, however, resulted in an extraneous solution, a number that looks like it's a solution, but it turns out not to be. Anytime you multiply through by a variable, it's essential that you take the answer that you get, plug it into the equation, and be sure that it works. Let's go ahead now and take a look at a few more problems here and we'll be done. Notice this time I have a square on my variable. This is a little different. To be honest, this truly makes it not a linear expression anymore. But your book adds these few extra examples with powers in this section, so I'm going to do the same. Once again, I'm going to solve it the same way. I'll do the opposite of my square, and I'll take the square root of both sides. Now, the obvious answer that students always give me is 6, knowing that 6 is indeed the square root of 36. But what you need to notice, folks, is that not only is 6 squared 36, but the number -6 times itself would also give us a positive 36. So there are two answers to this question. When you take the square root of 36, you could either get a positive 6 or a -6. And this is a perfectly legitimate way for you to leave your answer on the test as well. So let's go ahead and take a look at a couple more and we'll be done. Let's take a look at x squared equals 18. Once again, I'll do essentially the same thing. I'll take the square root of both sides of my equations. On the left side, my square and square root are opposites, so I am indeed left with x. But what will I do with the square root of 18? I'll be honest, on your test, if I don't direct you otherwise, you could merely put that into your calculator and come up with a rounded decimal solution and give that as an answer. This time, just for the heck of it though, I'd like to leave this in reduced radical form. The easy way to do this is to factor my 18. Now I factor that and I end up with 3 times 3 times 2. Realizing, of course, that the 3 times the 3 is the 9, and 9 times 2 is 18. And what I hope you notice this time, oh, by the way, don't forget the answer could be positive or negative here, is that the square root of 3, by definition, is the number you take times itself to get a 3. So when I take it times itself, I, of course, get a 3. So my answer is positive or negative 3 times the square root of 2. Let's take a couple other examples here. What if the square is just part of an equation? Well, to be honest, you'll solve this the same way you always do. I'll go ahead and subtract 18 from both sides of my equation, like always. And I am left, because these cancel on the left, with x squared equals -9. Now, folks, that's not a possibility. You cannot take the square root of a negative number. Any number times itself will always end up with a positive number. Remember, on our previous example, either -6 times -6 or positive 6 times positive 6 resulted in a positive 36. There is no number times itself that results in a negative, so this problem has no solution. Almost done, folks. Just bear with me here for a couple last examples. Here's a different one, and yet it's still kind of the same. But instead of just one variable that's squared, it's an expression that's squared. Well, once again, I approach it the same way. I take the square root of both sides. The square root and the square again cancel as always, and I'm left with x plus 2 on the left. On the right side, remember, the square root of 9 could either be a positive 3 or a -3. Now to solve for this, I need to eliminate the plus 2. I'll do that by subtracting 2 from both sides of my equation. These on the left cancel, and of course I have x equals plus or minus 3 minus 2. Well, this in essence means either I have positive 3 minus 2, or I have -3 minus 2, which actually leaves me with two answers. 3 minus 2 is 1. -3 minus 2 is -5. And finally, our last problem, folks. What if it's not a square? What if it's, say, a fifth root? Well, once again, I'll have to eliminate the coefficient. I will have to get that power by itself, this time by dividing by a -12. On the left, my -12's cancel, and I just have my x to the fifth. Dividing the right by -12 leaves me with a -3. Now, what's the opposite of a fifth power? A fifth root. So I'll take the fifth root of both sides. The fifth root cancels with the fifth power, and I'm left with x. On the right, I have the fifth root of negative 3. Now, there's things you could do with this, but honestly, if this is on the test and I don't tell you otherwise, just pull out that magic box of yours, plug it in, and come up with the appropriate equivalent decimal. So in this case, x equals negative 1.246.